Welcome to another deep dive. Today, we're going deep into the world of deep learning. You know how computers are learning to see? That's what we're exploring. It's a branch of AI that's totally revolutionizing computer vision. And we have this really cool review. It's from a few years back, but it unpacks how deep learning is changing everything. Self-driving cars, medical diagnoses, even restoring those old blurry photos, you know, the ones tucked away somewhere.
Yeah, it's amazing how much this field has just exploded. It wasn't that long ago. Computers had trouble just identifying like a handwritten number. And now we're talking about systems that can like understand complex scenes, track objects that are moving, and even generate these like realistic images.
So let's back up for a sec. What is deep learning exactly, and how is it different from the computer vision stuff?
So deep learning is a type of artificial intelligence. It uses these complex algorithms. They're called neural networks. And they're actually inspired by the structure of the human brain, like with these interconnected nodes that process information. And in computer vision, we train these networks on tons and tons of visual data, like think millions of images. And that lets them learn patterns and like see the world, kind of like how humans do.
Okay, that makes sense. But computers have been trying to see for decades. What makes deep learning so different? Like, what makes it the big game changer?
So before deep learning, computer vision relied on a bunch of different methods, like the Hare classifier. K means clustering, and support vector machines. These techniques were pretty good for like basic things, like face detection. But when things got more visually complex, they struggled. Deep learning, on the other hand, can handle that complexity with crazy accuracy.
Yeah, it's like deep learning has this way more powerful engine. So now computer vision can tackle things that it just couldn't before.
Exactly. And the real turning point came back in 2012 when this deep learning model called AlexNet won the ImageNet competition. That was huge GE. It really showed everyone the power of deep learning, especially for image classification.
Oh, yeah, ImageNet. That's like the Olympics of computer vision, right?
Exactly. AlexNet's victory was a wake-up call for the whole field. It used this special type of neural network called a convolutional neural network, or CNN for short. CNNs are designed to process visual info really efficiently by mimicking the structure of the human visual cortex. It's like giving computers their own special visual processing system.
So AlexNet was like the Usain Bolt of computer vision, just showed up and crushed all the records. So what happened next?
Well, AlexNet set off this wave of innovation, led to all these new CNN architectures. Researchers were constantly testing new designs, and each generation built on the success of the ones before.
Okay, so this is getting interesting. Let's talk about some of the key advancements. Like, where do we even begin?
Well, we can think of it like a family tree. Each branch is a new innovation. So after AlexNet came VGGNet. They went deeper, added more layers to the network, which increased accuracy, but it needed more computing power. Then there was GoogleNet, also known as Inception, and it introduced these innovative modules that improved efficiency without sacrificing accuracy. They released a few versions, refining it even more with each one.
So it's this constant search for the perfect balance between accuracy and efficiency. Did anyone figure that out?
That's where ResNet comes in. It tackled the vanishing gradient problem, which is this big hurdle that was limiting how deep these networks could get. Imagine playing telephone. The message gets all messed up as it goes through more people. The vanishing gradient problem is kind of similar. The info gets lost as it travels through the layers of the network. ResNet fixed this by adding these shortcuts that let info flow more directly, and that led to much deeper and more powerful networks.
That's pretty smart. So ResNet was like adding express lanes to the information highway. What about DenseNet? Where does that fit in?
DenseNet was inspired by ResNet, and it improved how info flows between layers even more, making the networks even more efficient and accurate.
Wow, so each new architecture was pushing the boundaries further. But what about running these models on everyday devices? Like our phones, that must have been a challenge.
Oh yeah, for sure. People wanted to run deep learning models on their phones, and that's what led to mobile nets. They were designed to be super lightweight and efficient. They used techniques like depth-wise separable convolutions to lower the computational cost without sacrificing too much performance. And like the others, mobile nets went through multiple versions, each one better than the last.
It's amazing how each generation learns from the previous one. But with so many options, how do you even choose the right architecture?
That's where EfficientNet comes in. It tackled the problem of scaling neural networks by systematically adjusting their depth, width, and resolution. This let researchers find the sweet spot for the best performance. They achieved state-of-the-art accuracy with surprisingly few parameters. It's all about finding that balance between power and efficiency.
So EfficientNet was like the Goldilocks of CNN architectures, finding that just right combination. What about RegNet? Is that like the ultimate one?
RegNet is really interesting. It combines manual design by experts with automated search by algorithms. It's like mixing human intuition with the power of computers. It might not be a huge leap in accuracy compared to EfficientNet, but it gives us new ideas for designing architectures in the future.
Wow, researchers are always pushing the limits. But with all these amazing architectures, what can we actually do with them? Like, what real-world applications have been unlocked by deep learning?
That's where things get really exciting. Deep learning has revolutionized 4 key areas of computer vision: recognition, visual tracking, semantic segmentation, and image restoration.
All right, let's dive into those. Recognition sounds pretty simple. Is it?
Well, recognition might sound simple, but it covers a bunch of different tasks. The most basic is image classification, like assigning a label to an image, like cat or dog or car. Object detection takes it a step further by not only identifying the object, but also pinpointing where it is in the image, like drawing boxes around every face in a FUD.
So that's how Facebook tags people in pictures.
Exactly. And within object detection, there are one-stage and two-stage detectors. One-stage detectors like YOLO and SSD prioritize speed, while two-stage detectors like the RCNN series prioritize accuracy. It depends on whether you need results fast or if you need them to be really precise.
So it's like choosing between a cheetah and a hawk. One's super fast and the other is super precise. So what about visual tracking? I bet that's super important for self-driving cars, right?
You bet. Visual tracking is all about following a moving object. In a video, it's like giving a computer the ability to lock onto something and keep it in view, even if it moves, changes how it looks, or gets partially blocked.
Yeah.
Deep learning has made tracking way more accurate, which makes applications like self-driving cars, surveillance systems, and even sports analysis much more reliable.
So deep learning is helping computers anticipate where a tennis ball is going or track someone crossing the street. That's pretty wild. Okay, so now what about semantic segmentation? What makes it semantic?
So semantic segmentation is all about labeling each pixel in an image with its category. It's not just about recognizing a car, but labeling every single pixel that belongs to the car, the road, the sky, and so on. This gives the computer a really detailed understanding of the scene.
So it's like giving a computer X-ray vision, so it can see not just the objects, but the whole scene in detail.
Exactly. One architecture that's great for this is the UNet. It was made for semantic segmentation, and it's super helpful for analyzing medical images. And then there's image restoration, maybe the most visually impressive application of deep learning.
Oh, yeah. Tell me about it. Is this what's behind all those crazy good AI photo enhancements online?
Yep. Image restoration uses deep learning to improve the quality of bad images, like removing noise, sharpening blurry pictures, and even increasing the resolution of old photos to show crazy detail.
It's like a time machine for images.
You could say that. Deep learning has done amazing things with image super resolution, letting us upscale low-res images to create high-def versions. It's even used to restore old photos and film footage, unlocking details, and giving us a clearer view of the past.
That's incredible. But one thing I'm thinking about is all these applications seem to rely on training computers with tons of labeled data. What if you don't have all that data? Can deep learning still work?
That's a great question. And it brings up a growing trend in deep learning research, supervised learning, where models are trained on labeled data. That's been the main approach. But researchers are looking into other options.
Oh, really? So what are they, and what can they do?
One that's looking really promising is semi-supervised learning. It uses both labeled and unlabeled data. This could be a game changer for when getting big labeled data sets is too expensive or takes too long. And then there's unsupervised learning, where models are trained without any labels at all. This forces them to learn from raw data and discover hidden patterns, which could lead to totally new capabilities.
So it's like letting these networks go explore and learn on their own. That's a cool idea. But before we get too deep into that, let's take a break and come back for part 2 of our deep dive. We'll be checking out the cutting-edge research that's shaping the future of deep learning in computer vision. Stay tuned.
Sounds good. Welcome back. It's kind of crazy to think we've only just scratched the surface of what deep learning can do in computer vision.
I know, right? Last time we went through like the whole evolution of these algorithms, from basic face detection to systems that can understand like whole scenes. And we even touched on how these advancements are changing fields like medicine and self-driving cars.
The coolest part is, this field is still growing like crazy. The review we've been talking about points out a bunch of key research trends that show us this future. It's going to be even more amazing.
Okay, so let's hear about those trends. What are researchers excited about these days?
Well, one big area is developing new types of networks and architectures that go beyond the usual CNNs. Researchers are always trying new things, pushing the limits. It's like they're trying to copy the complexity and flexibility of human vision.
It's like the smartest computer scientists in the world are in this race to build the ultimate visual processing machine.
Yeah, that's a great way to put it. Another trend is focusing on more specific applications. So instead of creating these general-purpose models, researchers are tailoring techniques for very specific tasks, like analyzing tiny images for medical diagnoses, or interpreting satellite images to monitor the environment.
Makes sense. Create specialized tools for specialized jobs. What other cool stuff are researchers working on?
There's a growing interest in combining computer vision with other areas of machine learning, like natural language processing. This could lead to some really cool experiences where computers can not only see, but also understand the world. Imagine computers that can recognize objects, but also describe them, answer questions about what they see, even tell stories about the images.
Wow, that's wild. It's like we're blurring the lines between how humans and machines see the world. So we're talking about AI systems that could describe a scene like a person, giving it context and meaning beyond just identifying objects.
Exactly. This combination of AI skills could totally change fields like robotics, where robots need to understand and interact with their surroundings in a more complex way. Imagine a robot that can not only move around a room, but also figure out what the objects are for, and then use them.
Okay, that's next level. Are there any other trends that you're excited about?
One that I find really interesting is how computer vision is being used in more and more fields. We're seeing deep learning being used in everything, from medicine and factories to archaeology and even art restoration. It's like deep learning is becoming this universal tool for understanding and interacting with anything visual.
It sounds like deep learning is breaking down walls between different fields, creating all these new possibilities for collaboration and discovery. But all this progress, it also brings up some important questions, like what are some of the challenges or potential problems that we need to watch out for as this technology keeps advancing?
That's a really important point. One challenge is figuring out how these models work, like how they make their decisions. As they get more complex and powerful, it gets harder to understand their reasoning. This lack of transparency can be a problem, especially in areas like medical diagnoses or self-driving cars, where we need to know why the AI made a certain decision.
So it's like we have this brilliant artist who creates these masterpieces, but can't explain how they did it. We can appreciate the art, but we don't really get the process.
Yeah, that's a good way to think about it. Researchers are trying to find ways to make these models more transparent, but it's an ongoing challenge. Another thing to think about is scalability. Training these complex deep learning models needs a ton of data and computing power, which can be tough for smaller companies or research teams.
It's like trying to build a skyscraper with only a few tools. You might have the idea, but you need the resources to make it happen.
Exactly. Okay. That's what people are working on developing, more efficient training methods and lightweight architectures that can run on less powerful hardware. This would make this technology more accessible and sustainable. We need to make sure deep learning is something that can benefit everyone, not just the big companies.
It's about making sure everyone has access, making sure it's not just a game for the big guys. Okay, so we've covered a lot in this second part. We talked about the exciting research that's shaping the future of deep learning and computer vision. And we even touched on some of the challenges ahead. But we're not done yet. In the final part, we're going to switch gears a bit. We'll move from the how to the what by looking at specific examples of how deep learning is being used in different fields, like how it's changing medical imaging and helping us unlock the secrets of ancient civilizations. Stick with us for the grand finale.
Welcome back to our deep dive into the world of deep learning and computer vision. So far, we've explored the basics, we've gone through the evolution of these crazy algorithms, and we've even talked about, like, the challenges and the opportunities that are out there. But now, it's time to actually see these advancements in action.
I know, right? It's amazing to think this tech isn't just some research project anymore. It's actually changing industries, solving real-world problems, and opening up possibilities that used to be like science fiction. Exactly. In the last part, we talked about all the cutting-edge research, but now I want to see how these advancements are actually being used. So where should we start?
Well, let's start with medicine. It's one of the fields that's being most affected by deep learning. It's crazy how this tech is changing things, like medical imaging, diagnosis, even treatment.
Okay, so tell me more. How is deep learning changing healthcare?
Well, for one, it's making medical image analysis way more accurate and faster. Algorithms can now spot these subtle patterns in X-rays, MRIs, CT scans, stuff that a human eye might miss. And that means earlier and more accurate diagnoses, which can literally save lives.
Wow, so it's like
Yeah.
having a second pair of expert eyes, working with the doctors, catching those tiny details.
Exactly. And deep learning is also being used to create personalized treatment plans by looking at a patient's medical images, their genetic info, and their lifestyle. Algorithms can help doctors figure out the best therapies for each person.
It's like having a custom medical plan made just for you. What other amazing things are happening in medicine thanks to deep learning?
Well, researchers are making algorithms that can predict how patients will do, which helps doctors make better decisions about treatment options. Deep learning is even being used to guide robots during surgery, helping surgeons perform these complex procedures with more precision and less invasiveness.
It sounds like deep learning is pushing the limits in healthcare, giving doctors new tools and insights to help their patients.
Absolutely. And this is just the beginning. We haven't even seen the full potential yet. But let's switch gears for a minute and talk about how deep learning is changing industry.
Okay, so what kind of industrial magic are we talking about?
One big area is automation and quality control. Deep learning algorithms can inspect products super fast and accurately. They can find even the tiniest flaws that a
Okay.
human might not see, so you get better products, less waste, and the whole manufacturing process becomes more efficient and sustainable.
So it's like having an army of inspectors working nonstop, making sure everything is perfect.
Exactly. Deep learning is also being used to make supply chains better, predict when equipment might fail, and even improve safety in factories and stuff. It's all about making systems smarter and more efficient by using data.
Wow, it's incredible how deep learning is being used everywhere. But you mentioned earlier that deep learning is also helping us unlock secrets from the past. Can you tell me more about that?
Oh yeah, for sure. This is one of the most fascinating areas for me. Deep learning is being used to analyze ancient texts, decipher old inscriptions that have faded, and even reconstruct artifacts that have been damaged. These algorithms can find patterns and figure out what things mean. Even when the data is incomplete or messed up, they're revealing stuff that we couldn't see before.
It's like having a digital archaeologist using high-tech tools to put together the pieces of history. Do you have any specific examples?
Well, researchers use deep learning to analyze these ancient papyri from Herculaneum. You know that Roman town that got buried by Mount Vesuvius? The scrolls were so damaged you couldn't unroll them without them falling apart. But deep learning algorithms were able to, like, virtually unwrap them and see the text hidden inside.
That's amazing. It's like we can hear those ancient writers, even though it's been centuries.
Yeah, it's pretty incredible. And deep learning is also being used to look at aerial photos and satellite images to find hidden archaeological sites. We're finding traces of lost civilizations that we might never have found otherwise.
Wow, so we've covered a lot in this deep dive, from the basics of deep learning to all these crazy applications in medicine, archaeology, and everything in between. So what's the main takeaway for our listeners? What should they be thinking about as we wrap things up?
I think the biggest thing to remember is that deep learning and computer vision isn't just about technology. It's a whole new way of looking at the world. We're teaching machines to see, analyze, and learn from images and videos in ways we never thought possible.
It's like we're opening up this whole new dimension of understanding, not just about the world around us, but also about history and even ourselves.
Exactly. And this is just the start. As deep learning keeps getting better, we can expect even more amazing applications in fields that we haven't even thought of yet.
Well said. That wraps up our deep dive into deep learning and computer vision. We've gone from the basic building blocks to the incredible applications that are shaping the future. But the journey doesn't end here. Keep being curious, keep exploring, and keep asking questions. Who knows what amazing discoveries are waiting for us? Until next time, keep exploring.